All right, so when you rotated the original image, which was in quadrant 1, these should have been the points that you got. All right, so basically, if it's rotating about the origin, that's why I said you might want to use the patty paper. You would sketch this on top of your patty paper. I would have stuck my finger on top of the patty paper right on the origin. All right, so when I rotated it, it wouldn't move. So then you can figure out where the new points would be. All right. Now, what this showed you guys is basically how the points should have changed. So if we started with XY, so that's the original point, XY. In other words, quadrant 1. Notice how the signs fit the quadrant, both are positive. All right. If you go 90 degrees, this is part of the next question. What happened? So 90 degrees counterclockwise, what happened to the points? Right, the y and x values flip. That's the first part. So the value that's in the x place is negative. Yeah. So the value that's in the x is negative. So that's 90 degrees. Now, let me ask you guys this. Does this point statement fit the type of points that need to be in quadrant 2? Right, because if you're in quadrant 2, that means the x value is going to be negative, the y value is going to be positive. And I'm talking about like the values that are in the space for x and y. All right. Now, turn it another 90 degrees to 180. So, again, we're starting with the pre-image. What happened to the points for 180 degrees in terms of the pre-image? So remember, pre-image is the image you started with. So ABC, not the primes. So what happened between here to here? What happened to the points? Lucas.
They were the same as the original, except they're just negative.
Right.
The x.
The x and y values are still in the same place, but now the signs flipped and they're both negative now. So instead of being both positive, they're now both negative. Which doesn't that fit for points being in quadrant 3? Both sides have to be negative? Exactly. Now, so that's 180 degrees. Now, 270. Again, look at it in terms of the pre-image. So ABC in quadrant 1. What happened to the points? Right. So they switched places again, but now the x that's in place of the y value is now negative. And doesn't that fit quadrant 4's specifications for points? Yes. So what I always say, because these rules will hold true regardless, I always think about it in terms of going from quadrant 1, quadrant 2, quadrant 3, quadrant 4. All right. So regardless of what quadrant you start with, these rules reign true. All right. So this will be how you find it counterclockwise for 90, counterclockwise for 180, counterclockwise for 270. Now let me ask you this. What about if you started clockwise? What do you think would happen? So instead of going counterclockwise, we went clockwise. So if we started in quadrant 1, which quadrant would we go to for a 90-degree rotation clockwise? 4. So what do you think the rule would be the same as? 270 counterclockwise. So this would be 90 degrees clockwise. What about 180? Where would it end up? Still the third. So 180, this is always the rule for 180, whether it's counterclockwise or clockwise. then what about 270 degrees? Right, it's now the second, so it's the same as 90. So clockwise, this would be 270 degrees. All right. So in reality, you really just need to memorize counterclockwise because clockwise would just be the same rules but going backwards. All right. Any questions on that part? All right, so that's what the 4, 5, and 6 we're talking about. Now, for number 7, all it asks is if a star in the coordinate plane has two of its points at 3, -5, and -2, -7. After rotation, the first point moved to -5, -3. So where did the other point move and how many degrees did it rotate? So if we look at the first point that we have, 3, -5, they switched y and x, and then what sign got changed? X. So how far did it go? Which rule got used? 90-degree what? Clockwise or counterclockwise? Clockwise. Or it could have been 270 counterclockwise. So it would give you the same image. More often than not, you will go counterclockwise, but be careful because sometimes they'll throw a clockwise at you. Any questions about the discovery part of the activity? All right. So here's the quick notes that you need to write down, which is literally just the rules for counterclockwise. And when you finish, take out your packet, turn to page 14. Make sure that mathematic is glued into your journal. It is another journal entry that you also have to come up with I can statements for. So once you finish writing that down, make sure your mathematic's in your journal. And then take out your packet, turn to page 14. That's where we're starting with notes today. So like I said, in reality, you just need to memorize for counterclockwise because clockwise just the same rules, just backwards. Yes, ma'am. It just says what? Oh, because 180 is going to be in the same spot, whether it's going clockwise or counterclockwise. Yeah. So 180 is always the same rule. All right. Is anyone still writing this down? I'll give you one more minute. Also, one more thing with homework. Yesterday I went and made keys for all 3 of the homeworks that we've done so far. So if you want to check your work, those are posted on the key page in Canvas. All right. And I will upload keys daily after the homework is due. That's not y'all. They got the wrong bells on. They had the ones that were supposed to be free yesterday. We're here till 9:05, guys. So we're good. Yesterday they were doing regular schedule. Today I guess they're doing homeroom schedule. Nope, 9:05. All right, everyone finished with this? Okay. So yeah, like I said, with your keys, this is the key page on Canvas. It has all the homeworks that we've just done, and I already made the keys for them. So if you ever want to go and check yourself, I'll usually post these probably the morning that it's due or after I check it or by the afternoon of the day it's due. All right. All right. So now we're getting into our more formal notes for rotations. So I'm going to try and get as much as I can done of this, but whatever we have left, what I'm thinking I'm going to do, because we got to move on to dilations to stay on track on Tuesday, I will finish the lesson by screen recording, and then I'll just have you guys watch that over the weekend. Is that okay with you guys? All right. So I'll still be teaching it. It's just going to be a screen recording, like YouTube video. All right. It's literally on YouTube. That's how I do it. And I'll post that on the notes page in Canvas. All right. But we're going to get as much as we can done. So with rotations, there are two parts of rotations that we're going to learn about. The actual concept of actually rotating and symmetry that happens when you rotate. All right. So first off, when we're talking rotations, the rotation of point A about, which means around, point C in a specific direction. Again, it could be clockwise or counterclockwise, and this is how you would typically see it. By a specific angle is accomplished by drawing a circle with a center at C and a radius at the segment CA. The image point is located on the circle such that the angle ACA prime is equal to the specified angle in the specified direction. All right. So that was a big mouthful. Basically, all that's saying is that the way I look at it is that, let's say you're trying to map out one big circle in the grass. All right. You took a stake, you stuck it down. That's your middle. You then had a string connected to it and you pulled it tight. And then you just walked in a circle with it completely tight. All right. The initial spot that you started with, let's say that's your A point. Let's say you only went about 90 degrees. That would be your A prime. All right. So it's almost like you're going around in a circle or like on a merry-go-round or a Ferris wheel. Okay. That's kind of what that means. So with this example, all right, circle O shown as below the points E, F, G, and H. Rays are drawn from O through each point of the angles created by adjacent rays are shown. Answer the following. So what two rotations about point O will map onto point E onto point G? So from point E to point G. So in other words, I'm starting here at point E and I'm going to end here at point G. Now, the two possible ways is just saying, okay, how many degrees would it be if I go counterclockwise? And how many degrees would it be if I go clockwise? So let's start with clockwise. So if I start at E and I swing around clockwise to G, how many degrees did I go? How'd you find it? That's a better question. 95 and 54. Good. So if you add 95 and 54, you should get 149 degrees. All right. Now, what about if you go counterclockwise? So you start at E, but you're going counterclockwise to G. How many degrees would that be? Right, 211. So you would add 121 and 90, so that'll give you 211 degrees. All right. Now, let's say we went from G to H. So now we're starting at G and we're going to H. So take a minute, find what it will be counterclockwise and find what it will be clockwise. So you're going from G to H now. Yeah, I got it frozen, so yeah. Here, I got the source remote. Yeah, the freeze mode. Guys, you're still just finding it right now. Thank you. No, you're good. I have a plug-in, so it works. All right, there we go. So, for clockwise, you should have gotten 90 degrees. And for counterclockwise, you should have gotten 270. Is that what you guys got? All right. Now, what's a strategy that you could also use if you didn't want to have to add up all three of these numbers right here to get the 270? How many degrees are in a circle? 360. So if you do 360 minus 90, you would have gotten 270. If you do 360 minus 149, you would have gotten 211. All right, that's another way you could have thought about it. Now, using a straight edge only, locate the image of point E after 180 degrees. We're not going to do that and label it point I. So I'm just going to take a shot in the dark because we know 180 degrees is just cutting it in half. So if I start at point E and I just go straight here, this would be about 180 degrees. And we're going to call that point I. Now, why does that not need to be specified of which direction we go in? Right, it's half the circle. So 180 degrees is half a circle. In other words, 360 degrees. So it would be the same distance in either direction. All right. Now let's actually get into some actual rotations. So we're going to rotate EFG 90 degrees clockwise about the origin and label the image E prime, F prime, and G prime. Now, we already know what the rule is for going 90 degrees clockwise. What is that rule? So we're going 90 degrees clock. I can't talk today. If we go 90 degrees clockwise, we start at XY, where we end up, what will the new point look like? Y negative X, good. So in other words, it's the same as if you went 270. So for example, if we start in quadrant 1, go 90 degrees clockwise, we end in what quadrant? Clockwise. 4. So that means that the new point, first off, you automatically have to switch Y and X for every 90 degrees. But the new point, since if we go from 1 to 4, that means we have to change from positive to having a negative in the y's place, all right, to fit the quadrant. That's what I always kind of say with rotations. Think about it in terms of if you're starting in quadrant 1, you would go that direction. You always flip every 90 degrees and you change the signs to fit the quadrant. All right. So for this one, like I said, we're going from y to negative x. So we're going to rotate these. So I'm going to start at E, which is at 1, 2. So E prime would be where? To negative 1. So I'm going to plot it at 2, negative 1. That's E prime. G prime would be where? 3, negative 4. Good. Now, those were the two that were in quadrant 1. All right. But F is in what quadrant starting out? 2. So where is it going to end up? What quadrant? If we go 9 clockwise. 1. Good. So that means that if we change the signs to fit the quadrant, first off, what would the new numbers be? 8, 3. Now, is it true that we made that x value, we flip that sign? Like we're supposed to. We're supposed to flip the sign of the x value. Is that true? Yes. Does that fit the points that should be in quadrant 1? What style of points should quadrant 1 have? Should it be like a positive, 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 negative, negative, positive, both negative, positive, positive? So that's what I mean by switch the signs, change the signs to fit the new quadrant. All right. So if you don't remember these rules, that's the way you can think about it. Flip it every 90 degrees, change the signs to fit the quadrant, the new quadrant. All right. So this would be at 8, 3. Oops, there it is. All right, and that's F prime. Now, let's say we went 90 degrees counterclockwise. So what's the rule for 90 degrees counterclockwise? So if we start at XY, we go to what? Negative Y, positive X. So we're still starting from our original points again. So E, that's in quadrant 1. So where's it going to end up? Or E double prime, where's it going to end up? Quadrant 2. All right, we're starting again with our black pre-image. All right. So it ends up in quadrant 2. So that means my new points are what? Well, 1, 2 is where we started. So what's the new points? Negative 2, positive 1. So guys, we're starting again with this image right here. All right. Just because it says double prime doesn't mean we're doing a second transformation. We're just doing a different transformation. All right. What about G double prime? It would be negative 3, 4. We switch them, change the sign to fit the quadrant. And then what about F double prime? So F double prime. F is starting in quadrant 2. So where would F double prime end up if it goes 90 degrees counterclockwise? Quadrant 3. So what should happen to both the signs? They should be negative. So that means we switch the 3 and the 8. So this will be 8, 3, but both of these should be negative. Does that make a little bit more sense what I mean by switch the terms, change the signs to fit the quadrant? Yeah. So imagine that they're just not negative to start out with. And then if you know you're going to quadrant 3, you know you should have 2 negative points. If you know you're going to quadrant 2, you know you should have 1 negative in the x value, 1 positive in the y value. All right, does that make sense? All right. So I'm going to graph these very quickly. So this will be -2, 1, that's E double prime. -3, +4, that's G double prime. And -8, -3, that's F double prime. Now, are all 3 of these figures congruent? Yes, they should be, because rotation is known as a what? It's a rigid motion. So yes, they're congruent because rotations are rigid motions. All right, guys. So the rest of this I will give to you in a video for rotations. All right. So I will post that on the note page in Canvas. It should be done by this afternoon. All right. So I'll do it during my planning period today. So after 4th period, it should be posted. All right. So it will be pages 15. Well, no, I lied. So this will be. Do you guys want me to do some more examples with rotation? That's the question. Okay, so I'll do page 15 with you guys, but then 16 is your homework. All right. And then I'll do page 17, 18, and then 19 and 20 is your other part of the homework. Yep. And I'll restate this in the video, and it'll also be posted in Canvas. All right. 20. The other pages I'm going to do in the video. Just finish copying down the notes. All right. I'll post it on Canvas, guys. Just check it. Oh, over the weekend. So it's due Tuesday. I'm checking it on Tuesday. That's on your cell. I'll finish the notes in Canvas. Yeah. Yes, but some of them are just notes that you just need to watch the video copy now. I want to record a video. I'm doing some extra. I want to do an extra example. Okay, guys, listen. Shh. All right. Here's how we'll shape this, because I can sense the confusion. 15 through 20 are the pages that's left. I will do some of them in the video. The ones that I don't do are homework. Got it? Okay. Does that make sense now? I'll also post a PDF of the notes as well. All right.
Wait, so we're basically just finishing the back like the videos.
Yeah.
Use the video and you just like do and then just finish the video.
Yep. So basically, yeah. So basically, I'll do the rest of the notes that you need in the video. That'll be like 2 or 3 pages. All right. And then whatever pages are left between 15 and 20, that's your homework. And I'll post the exact pages in Canvas if you need that. Okay? Does that make sense? All right. Just check Canvas. All right? It's all going to be there, I promise. Also, I should have those quizzes graded.